Can't see me. It's my face. Yeah. Cool. Welcome. This is the 9th homework help session, and there's 2 more to go. We got today, we got the next one, and then we got the last one. And those are the 3 homework help sessions that we have left. There appear to be 70 problems in the help session for today, or in the homework section for today. For the most part, I'm going to be moving back and forth between the question that's listed on here and going by paper. Rudy, what's up? Oh, all right. They don't want people in here. All right, I'm going to hop back and forth between the problem that's written up here and writing the stuff on paper. Thank you, Rudy. Appreciate that. Yeah, and we'll make the most of the 2 hours that we have right now before we get kicked out for whoever's coming in after us. The way these parts are divided is that for the first 5 or 6 parts or so, generally speaking, there's multiple questions that you answer from the same problem. So in the case of the first problem, we're looking at the U.S. dairy industry wanting to estimate the mean yearly milk consumption. So in that first question, as we break up all of these questions, we're working on story problems after all, that first sentence actually says that the dairy industry wants to estimate the mean. So if we were asked the question, you take a look at the sample quiz for modules 8 and 9, sample quiz 3, you see that it says, which variable are we estimating for? And this question actually says that the dairy industry wants to estimate for the mean. So it wants to estimate for mu. In the case of this problem for question 1, what is the value for the population mean? Well, what is the value for the population mean? Given those options, what is the value for the population mean? What do you say, Stephen? 60. Is it 60? I'm going to tell you, no, it's not 60. Because right now, we don't know. The answer to number 1 is unknown, and it's unknown because we don't know mu. We know things that we can observe, and the things that we can observe are sample level bits of information, things like a sample mean, a sample standard deviation, and a sample size. But in this case, when it says they want to estimate the mean yearly milk consumption so that they take a sample of 16 people and find that the sample mean is 60 and the sample standard deviation is 20, we don't have any population level information, which includes, do we have any population information regarding the actual mean? 1 is unknown. But for part 2, what is the best estimate for that population mean? 60. Is 60. So 1 is unknown and 2 is 60. 2 down, 68 to go. 60 is our best estimate. But we want to come up with a 90% confidence interval, and we need to come up with a value of t for this 90% confidence interval. All right, let's take this piece apart a little bit. We go to the document camera. Question 3, it's asking for a 90% confidence interval. But I still want to be able to take out the essential pieces of information from this question. And this says that from a sample of 16 people, that the mean yearly milk consumption is 60 gallons with a standard deviation of 20. So those are the three pieces of information I have right now. Is that the sample size was 16, the average for each of those 16 people was 60, and the standard deviation. In all cases, that's the sample mean, a sample size, and a sample standard deviation. We know nothing about the population. Question 3 asks, what's the t-value for a 90% confidence interval? So we're going to go to the t-table to get that information. But in order to get a t-value, there's one other statistic we need to calculate. In order to get a t-value, what's the thing we need? Chris?
Mu.
We don't need mu. Yep. We need degrees of freedom. And for our univariate example here, where we have one variable, we're just talking about the number of gallons consumed. How do you calculate degrees of freedom, Tiffany? N minus 1. So we're going to have 15 degrees of freedom. Now I know that we're looking for a t-value because the problem says, what's the t-value? But I've been known to make mistakes from time to time. How do I know that I should be using a t-value for my confidence interval rather than a z-value for my confidence interval? There's one thing that's given in the problem that determines whether or not I should be using t or z. What is the thing that's given to me, or rather, what is not given to me that determines whether I use t or z? Drew? Well, I'm always going to have sample information. I'm always going to have a sample size and a sample mean. And tell me more. Did I hear you completely? That was it? All right, Katie's going to jump in.
It gives you sample standard deviation.
Sample standard deviation, and that's the key. Yeah, for our standard error. So when we're doing a confidence interval for mu, we're always going to start with the same point estimate, same best guess. In this case, x bar. In some cases, we're going to use z. In some cases, we're going to use t. Z times the standard error, or t times the standard error, is the thing known as the margin of error. When we have t, when we have s, we need t. When we have sigma, we use z. If you like bad mnemonics, well, we know that s and t are right next to each other in the alphabet, so they go together. And this is not how you spell sigma. I don't know, that one's a bit of a stretch. It's a bit harder. But if you can just remember sigma means z and s means t, then you're in the right spot. So we still know we got to find t, and we're going to use 15 degrees of freedom for a 90% confidence level. We find t values from our t tables. And remember, if you don't have a t table handy, but you have a mobile device, say if, I'm going to show you real quick. Anybody lost a t table? Let's see if I'm still logged into Skype. Yeah. You can just as well go to the section in Sakai, which is marked statistical tables, and you can get something that looks an awful lot like what's actually here right on your phone. In this case, you go to the bottom where it says confidence level. Which confidence level do I use to find my t value? How much, Chris?
90.
How do you know?
Question.
It says so. How many degrees of freedom do I use, Tiffany? 15 degrees of freedom. He's right there at 1.753. That's my t value. So in order to get to the answer to question 4, which is what is the 90% confidence interval, we have to start with our point estimate, which is 60, and add or subtract whatever our margin of error is. In this case, our 90% confidence interval for pi, or for mu, x bar plus or minus t times the standard error, we need to use those two things in order to calculate the standard error. Standard error is s over the square root of n, 20 over the square root of 16. Y'all get 5 for your standard error? That's what I got, but I'm not always right. 5? Okay, thank you, Steve. Yeah. Do me a real solid if you're following along. I just want to make sure I'm doing these numbers right. That's going to help us a lot. So just a little bit that helps me out along the way. Awesome. Point estimate 60. Our z-value is 1.753. Our standard error is 5, which means this value should be something on the order of 8.7. Yeah, something like 8.76. I take 60 minus 8.76, and I take 60 plus 8.76. This one's easy. So I'm just going to look for the one that's got 68.76 in the answer, because that's the only one that can possibly be right. So the last question in part 1 says, based on your 90% confidence interval, is it reasonable to assume that the true population mean is 63 gallons? Mike, what do you say? Why is that?
Because 63 falls between 54 and 68.
Yep, because 63 is somewhere in this interval. I say yes. Questions on milk? Cool. 5 down, 65 to go. What, Curry? It seems like that many?
A lot.
Do you know how many are in the next section?
I've been told.
Yeah. By me?
Yeah.
Yeah. There's a lot. Don't worry. It's called practice. We're going to talk about Ms. Maria Wilson because she's considering running to be the mayor of Bear Gulch, Montana. If I'm going to ask you 70 questions, I should ask you something stimulating like Maria Wilson's running for mayor of Bear Gulch, Montana. You've been there, right? It's a wonderful, gorgeous town. Before completing these petitions, she decides to conduct a survey of voters. Surprisingly enough, a sample of 400 is not the entire population of Bear Gulch, but 400 is only a sample. She conducts a sample of 400 voters and reveals that 300 would support her in the November election. Estimate the value of the population proportion. So we're talking about proportions in this case, P's and Pi's. What's your best guess for pi? Well, it should be P. What's the value of P in this case? How much is P? How much? 0.75, about 75%. We got there because 300 people said they would vote for her, and she talks to 400 people. Therefore, P is 300 out of 400, which is 0.75. The next part of the question asks for the standard error. I mentioned this in the afternoon class today. From time to time, you see some different symbols for standard error. In this case, talking about the standard error of the proportion, using something simple and basic like that, SE sub P. Anybody remember the formula to calculate the standard error of the proportion? Yeah. Square root of P cubed over N. What's the value for P? 0.75. What's the value for Q? Yeah, thanks, Steve. If P is 0.75, Q is 1 minus P, 1 minus 0.75, otherwise known as 0.25. And what's the value for N?
400.
400. So we take 3/4 of 25 cents. I don't know how much that is. 0.25 times 0.25, 0.0625 times 3 sounds like 0.196 squared 5. I don't know. Somebody's got a calculator. Kurt, what you got? 0.0216 for the standard error.
2.16.
Steve, you got 2.16? 2.16 seems a little bit big. If it's 2.16%, that seems right to me. But the value of the standard error of the proportion is generally going to be on the order of things like this. That's about 2.16%, and that makes more sense to me than a whole value of 2. In the grand scheme of things, we know that somewhere between 0 and 100% of people can vote for Maria Wilson. We found P to be somewhere around 75%. And if we're going to come up with a confidence interval for pi, which starts at P and then adds or subtracts some margin of error, that margin of error should still be fairly small, like a couple percent. So in this case, the answer D is actually the standard error of the proportion. Now the margin of error is going to be something on the order of 2 times that, something like 4.5%. No matter what confidence level we use, 90, 95, 99, the Z value is going to be something around 2. Maybe a little bit lower, like 1.6. Maybe a little bit higher, something like 2.6. $1.645 or 2.576.
60.
6 to C, yeah. 0.75. So now we've got to get a, sometimes known as a test statistic or a table statistic. We got to come up with a statistic from this table in order to use our margin of error formula, which is the table statistic times standard error. In this case, we want the 99% confidence level. This is easy. We're using Z in this case because when we're talking about proportions and we're generating margin of errors for proportions, we're always going to use Z. We can use our t table, still using the same table, and we use the row marked z. There's a whole bunch of things up there. All these values up there, those are t values, but we don't need t values. What we need right now are z values. For, did we say the 99% confidence interval? Connor, is that right? Yeah. 2.576. That's our z value. I'm guessing the next question is, what's the confidence interval? Is that right? The next question, what's the confidence interval? That sounds about right. CI stands for confidence interval. It stands for confidence interval for pi. So we start with our value for p, which is 0.75, plus or minus some z value, 2.576. Times our standard error, which is something like 2%. We're going to end up with a lower bound. We're going to end up with an upper bound. What do you actually get for the value of the margin of error? The margin of error, which is your table statistic times the standard error. Feel like it should be something around 6%. What do you got? 5.5%. So 0.055. Is the margin of mine doesn't go there. The margin of error is this guy. .75 minus 0.055, 0.75 plus 0.55. Well, one of those is going to be closer than the other ones. So whether you get a value that's actually 0.055 or something like 0.056, I'm going to guess that's the right answer. Because that's about the value of 0.75 minus 5.5% or plus 5.5%. 9 down, 61 to go. Questions, comments, thoughts? Jamie, you good? You still searching? What's happening?
Okay, sorry.
You just making eyes at the table?
Yeah. I just missed, yeah.
No, I want to help, but it's cool. All right. 9 down, 61 to go. Zach Shadek, he makes screen prints. He prints stuff on cups. Is that his name? Yeah, it is. So Shadek Silk Screen Printing Incorporated purchases plastic cups on which to print logos for sporting events, proms, birthdays, and other special occasions. Zach Shadek, the owner, received a large shipment this morning. To ensure quality of the shipment, he selected a random sample of 300 cups, and 15 of those 300 cups were defective. That seems like a lot of defective cups. But our question is, first, what is the estimated proportion defective in the population? So what is the estimated proportion defective in the population? Looking at these examples here, only one of them makes sense without calculating a single one. First of all, if we're talking about proportions, the value should be less than 1. So of these 5 examples, only 2 are less than 1. I would eliminate anything which says that 285 is the proportion defective, or 15 is the proportion defective. That leaves us with either B, 95% are defective, or D, 5% are defective. What percent are defective? 5% are defective, otherwise known as 15 out of 300. If P is 5%, what's the value of Q? 95%, 0.95. Yep, we're going to answer those same 4 questions. We're going to need to know what's the standard error, what's the 90% confidence interval, and we want to know if there could potentially be 10% defective. So those are the questions we're going to ask, and we're going to answer. In order to calculate a confidence interval for the proportion, we start with P plus or minus the standard error. Wrong standard error. Don't make mistakes. P, 0.05, some Z value. Z value comes from the table. What's my confidence level, James? 90%. So what's the Z value? 1.645. Which row did you look in? Z. Yeah, row marked Z. Do we ask for a 90 or 95% confidence interval? 95? All right. If it was 90, it would be 1.645, and that's what I asked you, Jamie, but I think you may have read the question wrong. 95% confidence interval. So what's the Z-score for a 95% confidence interval? That one should be easy. 1.96. Thank you much. P, 0.05, Q, 0.95, N, what's the value for N? Want some other people to prove to me that they're here if you don't mind. Reynolds, yes please. 300, thank you. How do you know? It's the sample size. Because it says next to the letter N, 300. So somewhere around 5%. Plus or minus 1.96. What's the value for the standard error proportion? Because it looks like we're asked for that in the question. What's the actual value of the square root of 0.05 times 0.95 divided by 400? Who's got that one? Jackson, is that you up in the corner?
That is me.
Hey, what's happening? You got this value? Curry's got it. Just ask him.
0.0125.
0.0125. Y'all got 0.0125? So the standard error proportion, you say 0.0125? Yeah, that seems like it's about right. Because then approximately 2 times that gives us maybe 2.5%. What value do you get for the margin of error? Kirby, you got that one too? That's okay if you don't. Have you got that one? No, I'm running down the line. You better believe it. Megan's going to help you out. Thank you, Megan. Yeah, 0.0247, 0.02, let's call it 5, 2.5%. Because really the question we're asking is Zach Shadek gets to send them back if something like 10% are defective. But our 95% confidence interval will take 5% minus 2.5%. We'll take 5% plus 2.5%. Our 95% confidence interval for pi, we're 95% sure that the proportion of defective mugs or cups or whatever they make is somewhere between 2.5% and 7.5%. Zach sends them back if 10% are defective. Does Zach send them back? Zach, what do you think? Why not? Exactly. 10% is above our interval, therefore we don't send them back. You got all your homework questions answered there? Yeah. All right, 13 down, subtraction to go. I need to do this real quick because I'm thirsty. Pace check. Too slow, just right, too fast. Where are we at? Good. I see thumbs. I see nods. I see thumbs. I see nods. I see a thumb. Cool. Appreciate it. We're a little under pace to get done by 7, but don't you worry because there is a huge chunk somewhere towards the third quarter where all we're doing is knocking out t-values from the table. So you just stare at the table and find intersections in your toaster's Christmas. It's pretty easy. But we're not there yet. Right now we're talking about hot pockets at GM, or turnovers at GM, turnover at GM. Random sample of 85 group leaders, supervisors, and similar personnel at General Motors revealed that on average, they spent 6.5 years in a particular job before being promoted. The standard deviation of the sample was 1.7 years. By the way, that's GM. That's a company that used to exist and manufacture cars in the United States. Forgive me if this work is a little bit dated. I'm not even sure if GM is still around. GM still around? Yeah, all right. So they still exist. They once did too, but they still do as well. That's GM. But we have a random sample of 85 group leaders, supervisors, etc. We have a mean and we have a standard deviation. Here's my question for you. Is any of the information up there population level information? If so, which piece of information up there is population information? Any piece of information up there, population information? If so, which piece of information? Samantha, I'm going to ask you. No, what? No, I am asking you.
Yeah. No.
Nope. None of it's population information. That entire sentence is talking about their sample. So if we're talking about a mean, it's a sample mean. If we're talking about a standard deviation, it's a sample standard deviation. If we're talking about a size, it's a sample size. All that information, X bar, S, and N. I'm writing it down. Don't worry. I'll show you in a second. Is exactly as described. But which variable are we estimating for? We're only ever going to be estimating for some population level variable. We'll never be estimating for sample information because sample information is always observed. Given that we are provided a mean, a standard deviation, and a sample size, Leah, which one are we estimating for or estimating? Yeah, we're going to try to estimate from you. Thank you very much. What's my point estimate from you? What's my best guess from you? Should be X bar. Leah, let me stick with you. You're That's okay.
6.5.
Yep, 6.5 is the sample mean. That's my best guess from you. What's the appropriate table statistic? Because we have S. Steven says T. Liv, do you agree with Steven?
Yeah.
As well, you should. Very good. T, because we have S, which means we're going to need degrees of freedom. So we're going to need to come up with a table statistic. We're going to need to come up with a standard error. We're going to need to come up with the margin of error. We're going to need to come up with the 95% CI, which means our confidence level is 95%. So, that's all work we need to do. Here's where we're going to introduce something new about the work we do here, because if you haven't noticed, this T table is not infinitely long. So if you're jumping ahead to trying to sort out what the value for T is, we need to know what the degrees of freedom are. Degrees of freedom is n minus 1. So how many degrees of freedom is that, Phil? Degrees of freedom is n minus 1. N is 85.
84.
Yeah, 84 degrees of freedom. If I come to this table and I try to find in the degrees of freedom column, I can't find 84. Oh no, my table's broken. I give up. Math is hard. Or you go to the bottom, and I know this is not an exam, but the bottom says, for the purpose of this exam, scratch this out and put this whatever. If you cannot find a value that corresponds to your degrees of freedom, which we cannot, use the value that is closest to yours. So we cannot find 84 degrees of freedom. Which is closer to 84, 100, or 80? 80. So we're going to use 80 degrees of freedom instead. The confidence level we're working with is 95%. So somewhere around the 80 degrees of freedom for 95% means that that's the value, 1.99, that we use for our... 1.99 is the value that we use for our table statistic. Check this out, like that's for 80 degrees of freedom. But the difference between 80 degrees of freedom and 100 degrees of freedom for a table statistic is 6/1000ths. That's dust. And that's only part of what goes into the actual margin of error. T value, 1.999. I got to get the standard error. Standard error is going to be the standard deviation divided by square root of sample size. Jack, is your calculator hot? What'd you get for a standard error here? 1.7 divided by the square root of 85. Square root of 85, something like 9. 1.8 divided by something a little bit more than 9 should give me a value somewhere around 0.4? 04? How much? 0.18? All right, yeah, that's why you got calculators and I don't. It's all just make stuff up. Christine, 0.18 yet?
Yeah.
Yeah. .18. Margin of error is going to be Z times my, T times my standard error It looks like 2 times 0.18. I'm going to guess my margin of error is something like 0.36. If you're cool with that, I'm cool with that because the answers are multiple choice anyway. 95% CI from you. Point estimate, plus or minus margin of error. Point estimate, 6.5, plus or minus the margin of error, 0.36. Means I'm going to get something whose upper bound is 6.86. I don't see 6.86 up here. I see 6.68. That's pretty close to 6.86, right? So I should choose this one, right?
No.
No! Hey, this is fun. Let's try it that way. No! What's better than that?
6.87.
6.8. Oh, because 6.87 is close to 6.86, even though it's closer. I'm ready if you are. Let's have some fun. Could use it on a day like today. I've been so sad all day because of the stupid snow. Jackson just made me laugh. You win for the day. You can have one of these dry erase markers. I swear they work really well, right? Anybody who has platinum knows that's totally the case. And then whatever this one is, it's probably like 6.13. Hey, there's your answers. Any part of those homework questions that didn't get answered you need some help for? Onward and upward to infinity and Katie?
What was 19, the value of the margin of error?
Margin of error is something like 0.36.
Okay.
Is it on there? Sweet, 0.36. Cool. 20 down, 50 to go. We just made up time. '21. A recent survey of 30 executives. Recent survey of 30 executives who were laid off during a recent recession revealed that it took a mean of 26 weeks for them to find another position. The standard deviation of the sample was 6.2 weeks. Construct a 90% confidence interval for the mean. Okay. We have a bunch of information up there. Is any of that information population level information? Yes or no? I'm going to move it. What you want me to step on it? All right. Steven? No, none of that information is population information. So if we have a mean, a standard deviation, a proportion, a size, all of those things are sample level information. Are we talking about averages or are we talking about proportions? Averages, proportions, and how do you know? Yeah, it's averages because it says the word, what, average or mean? Mean, yeah, talking about means. So we're going to be talking about means and standard deviations. If we're talking about means and standard deviations, are we estimating for mu or are we estimating for x bar? We're estimating for mu because we know x bar. Whatever mean is given up there is based on our sample. So we're estimating for mu. What's the value for my best guess of mu? What's my best guess for mu? Megan? 26, sounds good to me. What's the appropriate table statistic T or Z, T or Z? How do you know T or Z? Say what, Ab? Sample what? No, we always have a sample mean. Just run down the list. It's not mean. Yeah, it's T because we have sample standard deviation. In this case, we have S. When we have S, we need T. Appropriate table statistic is T. Then we got to find the table statistic, the standard error, the margin of error, the 90% confidence interval. Then we got to ask a question about 28 weeks. So I'm going to pull out the essential information, and that is our sample mean is 26. Our sample standard deviation is 6.2. Our sample size is 30. We need to find t. In order to find t, there's something else we need. I know our confidence level is 90%, and we're asking the question, is it reasonable that mu could be 29? Right? Right. So by now, these problems just have a whole mess of parts. As long as we're able to identify the symbols that are associated with those numbers, we can assemble those parts into our own little Frankenstein's monster that we call a confidence interval. And a confidence interval always starts with a point estimate plus or minus the margin of error. In this case, we need a 90% confidence interval for mu, which starts with a point estimate plus or minus t times the standard error. You got X bar, which is 26. Tiffany? Yes, please. There's a question mark after it. Because I want to know in the last part of the question, and that was just me running down the questions that we needed to answer. In question 28, it says, is it reasonable to suggest that the population mean is 29 weeks? So that's why it says mu equals 29. That's how you pronounce a question mark. Very good. Basically, I just run the lines at this point. So we got to come up with a t value here. There's two things we need to know in order to get a t value. What are the two things we need to know in order to get a t value? Lauren. Degrees of freedom, and that'll determine which row. All right. What's going to determine the column? Quotes, confidence level. Confidence level. Yeah, confidence level. So degrees of freedom determines the row. Confidence level determines the column. In this case, n is 30. So what's my degrees of freedom, Lauren? 29. 29. N minus 1 or 29 degrees of freedom. Confidence level is 90%. 90%. 29 degrees of freedom. Looks like 1.699. So I've got X bar, it's written over there. I got T, it's written over there. Shoot, I do not have S sub X bar. Katie, how do I calculate standard error? Yeah. Yes, it is. Very good. So I'm going to calculate my standard error. Jane, you confirm? You concur? Will you, or did you have a question?
Oh, no.
Okay. Cool. Standard error is 6.2 divided by the square root of 30. That's a value somewhere around 1. Chris?
1.132.
I like 1.1. I like 1.132. 2. Yeah, that sounds good. Looks good. 26 is X bar. Zach, do I get confirmation on that value for the standard error? Yeah. So I think that's something that was asked for. I think that's something that was asked for. Whatever the t-value times the standard error, that gets a margin. Ooh, that value could be close to 3. I'm really curious, because if that margin of error is more than 3, then 29 is a reasonable guess for mu. But if the margin of error is less than 3, 29 is not a reasonable guess for mu. 1.699 says 1.132. Tiffany? 1.92. That's not anywhere close to 3. Confirmation on 1.92? I see 2 thumbs and get a yeah from Stephen. Means my 90% confidence interval for mu is, something around 24.08. Something as high as 27.92. So, running down the line, it looks like our table statistic is 1.699. Our standard error was something like 1.13. Our margin of error is something like 1.92. Our 90% confidence interval is something like 24 to 28. Mu equals 29? What do you think? Megan?
No.
Why not? Bingo. It is not in the interview. Mu does not equal 29. Es impossible. 28 down. Oh gosh, 42 to go? Yeah, take a deep breath. We're doing good work. Marty Rawati. My good friend Marty Rawati, the Y King of South Jersey. I mean, I think it's South. Yeah, it says South Jersey. All right. Marty hangs out the Y. This is the stories he tells. He recently assumed the position of director of the YMCA of South Jersey. He would like some current data on how long current members of the YMCA have been members. To investigate, suppose he selects a random sample of 40, that's 40 current members, the mean length of membership for those included in the sample, because how many different ways can you say sample mean? The mean membership length for those included in the sample is 8.32 years, and the standard deviation is 3.07 years. Is any of that information population information? Is any of that information population level information?
Chris is trying. Appreciate it.
No! It's all sample information. Sample mean, sample size, sample standard deviation. In which case, we're going to be estimating for a variable. Which variable are we estimating for? Mu. We're estimating for mu. What's the value of the point estimate?
8.32.
Thanks, Stephen. 8.32, because that's our sample mean. The mean of the sample is 8.32 years. In case you're curious, it is still snowing. So the sample mean is 8.32. Sample standard deviation 3.07. And the sample size was 40 current members. So we know we got a point estimate. We're going to have to choose the table statistic, T or Z, T or Z. How do you know T or Z? Which one is it?
T.
Thanks, Stephen. Why T?
Golfing.
Because I'm golfing. No, yeah, well, that was my cue.
Yeah. You have to be on sample standard deviation.
Says Mr. Stephen Simon talking about sample standard deviation. It's just a little corner S's over there. Done. So we're going to use T. Now we got to call for the closest value for the table statistic of the 90% confidence interval. It looks like our confidence level for Marty Rawadi, the Y King of South Jersey, confidence level for these estimates is going to be 90% confidence level. We're going to need the standard error, the margin of error, 90% confidence interval, and we want to know if mu equals 10. Because we're using T, there's another statistic that we need in order to help us determine T. Because we're using T, we also need what? Christine? On point, thank you. How many degrees of freedom we got here? 39. That's 40 minus 1, otherwise known as 39 degrees of freedom. My 90% confidence interval equals x bar plus or minus s. Well, I can write that backwards. I don't know. Kind of like writing the t first. Yeah, I kind of like that one better. Same thing. Don't confuse yourself. Ooh, I need to get what that t value is. And ooh, I need to get what my standard error is. Who wants what? I want somebody to tell me a t value. What t value do I need? Kyle, yes, please. 1.684. That sounds like it could be right, but how'd you get there? How many degrees of freedom?
39.
I don't see 39, Kyle.
So you go to 40.
Oh, okay. 40's close to 39. Go on.
Can you go over 90%?
90% confidence level, 1.684. That's a pretty good t value. Good work, Kyle. Thank you. Standard error. Standard error, standard error. Chris, I know you got the answers. I can't call on you every time, though. Stephen, I know you got the answers. I can't call on you every time, though. I need some help from other people. Drew, help me out, please. 0.49. We get confirmation on 0.49. You gentlemen give me confirmation. We'll keep us moving. Yeah. What's up, Jackson? Confirmation? 0.49. In other words, the standard error is 3.07 divided by the square root of 40. 0.49. 8.32 plus or minus a t value of 1.684 times 0.49. 8.32 plus or minus half of that. Ooh, I can do that. That should be something like 0.842. Is the margin of error 0.842? Lauren? 825? 825? How? All right, you know what? I'm just looking at 0.49. Looks like it's almost 50%, and I was just taking 50% of that, but I suppose you're probably right. I thought I was going to get one of these. Not today, my friends. 0.825. That's my margin of error. So I take 8.32 and I subtract 0.825. And I get something like 7.495 for the lower bound. Liv agrees with that. I'll take it. I can also add 0.825 to that, and that one looks harder. Addition is tougher than subtraction. I was going to say 9.1 for what, 2?
145.
Okay. Ooh, and we also have to answer the question 10. Connor, 10? No, why? Very good. Opportunity interval. Yep. That's not the secret knock. Cool. So I believe all of the pieces have been correctly identified in this problem. Let's run them down real quick. We're estimating mu, the point estimate's 8.32. We're using t to get there. T statistic is 1.684. The standard error is something like 0.49. Value of margin of error appears to be something like 0.83. 7.50 and 9.14 appears to be what our values round to. Connor says no, 10 is not reasonable. Why is 10 not reasonable, Connor? We got two options. Is it above the upper limit or below the upper limit?
It's above the upper limit.
It's above the upper limit. Very good. Cool. 36 down, 34 to go. And we're now on pace to complete this entire thing before 7 o'clock. You didn't think we could get it done, did you? I'm looking at you, Kurt, because you didn't think we could do it. No. See, who did I miss? So I missed a couple of people. Brendan sort of got through without being noticed, but not very much longer. You're going to talk about the NCAA practice schedule for me a little bit. By the way, the NCAA is the National Collegiate Athletic Association. It's important to spell out your acronyms. They reported that the mean number of hours spent per week on coaching and recruiting by college football assistant coaches during the season was 70. A random sample of 49 assistant coaches shows that the sample mean was 68.6 hours with a standard deviation of 8.2 hours. Brendan, here's my question. Is any piece of information up there population information? If so, what? There's one piece of information up there which is not sample information, which is, let's say, an expected value, which is a claimed value, which is a value that was not something that was acquired by you making the observation. Which value is that? It is, in fact, 70 hours. In this case, we basically got two statements. One is a statement made by the NCAA, where they make a claim, which is effectively what we had done in the previous one, which was 10, or the one before that, 29. In this case, it's the NCAA going 70. And you may or may not believe 70. So you go out and you collect information from 49 assistant coaches, and that's their sample size. And what information do we collect from those 49 people, Brendan? Very good. So if we collect the sample standard deviation, what's the appropriate table statistic to use? Thank you. Sorry, I almost got all WrestleMania on us. 13 suplexes. That's so many suplexes. It's well above the mean. No? No one? Trust me? All right, cool. It's all right. I mean, I've never been to a real WWF match. When it was called WWF, Jake Snake Roberts anyway. We're going to talk about some stuff here at the NCAA. I'm going to pull out the essential information first and then run down the questions. What the NCAA is basically telling us is they're making the claim that 70 is the population mean. But we find a sample mean of 68.6 with a sample standard deviation of 8.2. And we achieve this by collecting information from 49 assistant coaches. Brendan tells me that we need a t-value. Degrees of freedom, something we need when we do t. We're probably going to need some sort of confidence level in order to construct an interval. Mu, pi, x bar, s, sigma. Which one are we estimating for? We're estimating for mu. We've got a bunch of stuff in here that's talking about means and standard deviation. We'll never estimate for a sample observation because we don't need to estimate for it. I observe it. I don't need to estimate how many pens are in my hand because I can look at my hand and count the number of pens, and that number is 1. But in the case of this, we're estimating for something we don't know. We're estimating for something that the NCAA is trying to claim. And we come up with the point estimate. What is the value for our point estimate? What is the value which we observed? Connor, what did we observe?
68.6.
Yeah, we observed 68.6. The appropriate table statistic, T or Z, T or Z. How do you know T or Z? Tiffany, how do you know? Because you got sample standard deviation. When you got S, you use T. We got sample standard deviation. Looks like we're going to be asking for a confidence level, 99%. We're going to come up with the standard error. We're going to come up with a margin of error. Looks like we're coming up with a 90% confidence interval too. Looks like we may be hopping back and forth. So in question 40, just so we run these out, if in 40 we need the 99% T, but in question 43 we need the 90% CI. Oh, it looks like in question 45 we're also asking for the 99% CI. So we're probably going to need to come up with 2 separate confidence intervals. Confidence interval is a point estimate plus or minus a margin of error. A margin of error is composed of a table statistic multiplied times a standard error. If we change your confidence level from 90% to 95% or to 99%, does the standard error change? If we change our confidence level, does our standard error change? Katie, what do you say? No, why not? Because it has nothing to do with the standard error. What goes into the standard error? Two things go into the standard error: standard deviation and sample size. I can change confidence all I want, but the standard error doesn't change. But when I do change my confidence level, that's when the table statistic changes. Confidence level changes the column I use in my T table. So in the case of a couple of different problems that we're working on here, the first thing we need to do is actually this one. We're going to find this one along the way, but it's easier to look up. So what we're going to work on right now is coming up with a 90% confidence interval for mu. X bar is 68.6. I need to get a T value, and if I'm doing a 90% confidence interval, I need degrees of freedom. How many degrees of freedom? 48. 48. N minus 1, N is 49, 48 degrees of freedom. I don't have 48, so I'm just going to go ahead and use 40. And for a 90% confidence interval, we use 40 for 90%, and again I get 1.6840. And that's for a 90%. Standard error. Ooh, I almost almost got this one in my head. It's 1.1 and something. 1.1 and something. 1.1 and what? 1.17. So that's really 1.2. Can't catch a break. So 1.17. So again, if we change this from a 90% to a 99% confidence interval, that value of 1.17 will not change. The standard error is not affected by our confidence level. So what do we get when we take 1.687 times 1.17, the margin of error for a 90% confidence interval? Steve?
3.16.
Katie, you got 3.16 there?
I brought 1.97.
Where do we go wrong, Stephen? Do you know? You got both of those?
What, 1.684 times 1.17?
Yeah.
Maybe I'm looking at.
Yeah, no. Could be. What did you say, Katie? 1.94?
1.97.
Yep, that's right.
1.97. So, that's roughly 2. $68.6 plus or minus 2 gets something like 66.63. Something like 70.57. Let's see what's happening on this problem here. Something here smells funny. Well, let's take a look at the different parts. Oh, we still got to get a value for a table statistic for the 99% confidence interval. 99% confidence interval for 48 degrees of freedom should be something like 2.704. That's our answer to question 40. The value for our standard error. And here's the challenge. Oh, no, this isn't the challenge yet. Standard error should be, what, 1.17? We got 41 right, too. Margin of error. We don't have the right margin of error for this choice. Say what happened. Someone came out to me on Friday and said, hey, Jeff, something's wonky here. We go 90%, we go 99%. I looked at it and go, oh, that one should be 90%. And I changed the round one from 90 to 99. Now we got a couple of questions in here that are a little bit wonky. So I'm going to go in and I'm going to refresh these to get this stuff right. It's a little screwy right now. My bad. Don't worry. You won't be penalized for it. There's gifts that come back to you on that stuff, which is why we go through the problem and just say, what's the 90% confidence interval? Because I suppose if we were looking for the 99% confidence interval, the margin of error, which is affected by our choice of confidence level. Because if we used a t-value for a 99% confidence level, CI from view. See, Samantha? Yep. We'd still start with 68.6, but we'd have a t-value for a 99% 2.704. Our margin of error, or standard error, would still be 1.17. Now, Steve, what do you get for a margin of error? 2.7 times 1.17. I thought that was the one that you went earlier.
Yeah.
You got that one?
3.1.
3.16. So now 3.16, or in our case here, 3.17 is the value for the margin of error for the 99% confidence interval. However, because that margin of error doesn't specify which confidence level you should be using, and it doesn't specify up in the top what confidence level you should be using for the entire problem, that makes things get a little wobbly. But in this case, the 99% confidence level margin of error is 3.17. And if you start at 68.6 and you add 3.2, which is roughly what that is, you get something like 71.8 for your upper bound. So the closest to the 99% confidence interval is actually listed here. Chris?
So would that mean that 44 is yes?
Well,
70?
70, no matter which interval you use, whether you used that interval or the one which went up as high as 68.6 up to something like, what did we say? 71.8. Either way, 70 is in there, or 70 is in there. 70 is a reasonable value because 70 is contained within that interval. How are you doing, Rudy? Right there?
Yeah.
Yeah, so let's take a look back at those homework problems. Yeah. I put A for 43.
It's 42A or is it?
No, it's totally D, but when I hit the up arrow, it changed where the radio went. We can take a deep breath here because this is part 7. Yeah. Sorry, there it goes again. I'm just trying to scroll down the page. I'm not trying to change the answer. We make the interval larger, it's still in that interval. Yes, it's still in that interval. Thank you, Katie. $45 down, 25 to go. 39 minutes to get there. Can we do it? Can we do it? Yes, why not? Let's do it. For a bunch of these, sample is 49 observations is taken from normal population with a standard deviation of 10. 10 over 7 is our standard error. 10 sevens, 3 sevenths, 1 3/7. That's our margin of error. Sorry, our standard error. Sample mean is 55. Determine the 99% CI given that information. So in the case of 46, we are told that we have 49 observations. We have a standard deviation of 10. And that the sample mean is 55. determine the 99% CI. Here's a question. We spent a lot of time talking about T or Z in this instance. Which one do you think we use here? Why is that, Steve?
Since we have a population, the standard deviation of 10.
Okay. Katie, what do you think? Which one? Why T? So we have a sample mean of 55, and that's true. But the thing we're concerned about for determining if we use Z or T is the standard deviation. And in this first statement, it says we got a population with a standard deviation of 10. So that standard deviation in that first sentence is a population with the standard deviation of 10. So in this case, that standard deviation is sigma. It's a population level standard deviation. So if we have sigma, because of population level standard deviation, what do we use, Z or T? Z. In this case, Z. A 99% Z is 2.576. I gotcha. That's not the secret knock. All right, he knows the secret knock, so I think he's the spy. Nailed it. Love to see it. So that's all the information that we have in this problem. We can use those two pieces of information to get our standard error. 10 over the square root of 49 is 10 over 7. 1/7 is 0.14, so 3/7 is probably like 0.42. So I'm going to say our standard error is probably like 1.42, maybe 1.43, 1.43. Yeah, got one. Standard error is 1.43. My 99% CI from you is X bar plus or minus Z times the standard error. 55 plus or minus Z times the standard error. What's the margin of error? Drew, you got that margin of error?
3.68.
Confirmation 3.68. Is that head on? Yeah, Megan's on board. 3.68. So I'm going to choose the one with the upper bound at 58.68. I hope one of those has an upper bound 58.68. That's the one I choose.
I have a question. How did you get Z like number from the table?
So you know we're using Z, right? Okay. There's a row right here which says Z. So whenever I need a Z value, I come to this row. What's the confidence level that's given to me in the problem? I come over here where it says 99. I use the row mark Z. It's 2.576.
Oh, okay.
Question 47. Research firm conducted a survey to determine the mean amount steady smokers spend on cigarettes during a week. They found the distribution of amounts spent per week followed the normal distribution of the population standard deviation of $5. A sample of 49 steady smokers revealed that $20 something equals $20. I'm guessing that's mu. I'm going to go ahead and say that the mean is mu. Yeah, because all those look like they're centered around $20. We're going to use Z or T here, Z or T. How do you know Z or T? Rudy, which one? Nope. Yeah, all right. You know what you're looking for to determine T or Z? Bill, do you know what you're looking for to determine T or Z? Right, but what do you see in this one? Yeah, you see population standard deviation. Is population standard deviation sample standard deviation, Phil? No, it is not. You use T when you have sample standard deviation. Population standard deviation is sigma. So in this case, we have X bar equals 20. Sigma, which is the standard deviation, is 5. N is 49. And we want to come up with the, what's that look like? 95% CI. So we're going to use Z in this case because we have population standard deviation. Hey, Katie, can you help me find the Z we need for this confidence interval? We're going to use Z, and we got a 95% confidence level.
So you go down to 95%, and then you do 40, but there's no 40, so you do 40, so you do 2.021.
Nope. So we're using T or Z in this case? Nope. We're talking about Z in this case.
Okay.
We got sigma equals 5 because the question said we have the population standard deviation, sigma. We have population standard deviation is 5.
Okay, so it'd be 1.960.
Exactly. Because the question says population standard deviation, we got sigma. And when we have sigma, we use Z. So in this case, our 95% CI for mu, X bar plus or minus Z times the standard error. Standard error is going to be 5 divided by square root of 49, which feels like it's around 72 cents. Maybe 73. 0.72, 0.73. 0.714. Oh, okay, to get that one right. Rough day, Jeff. X bar is 20. Z is approximately 2. Standard error is something like 71 cents. 2 times 71 cents is about $1.40. My margin of error 140. What do you get for the margin of error? 1.96 times 0.71. Drew, what do you got there? 3.9?
Yep.
Cool, thank you. So it looks like the upper bound for this one, $21.39. Find me one that's got something like 21.39. Uh-oh. I don't see 21.39. What's close to 21.39, Jax? 21.40. You can do the upper bound and the lower bound, but it's so much easier just to add. 47 down, 23 to go. Don't worry. When we get to questions 49, 50, and so on, you're just looking up T values for a little while. We're going to skip those. It's time for a fictional problem. Dr. Patton is a professor of English, and she recently computed the number of misspelled words in a group of student essays. The reason it's fictional is because she noticed that the misspelled words per essay follow the normal distribution. That's not something that the profession of English does. I'm sorry. No offense to professors of English everywhere. I know some. They don't do that. But we found that the population standard deviation was 2.44 words per essay. In one section of her class, she's got 40 students. Yet again, fictional problem. Those English classes don't have 40 students in them. The mean number of misspelled words was 6.05. Construct a 95% confidence interval for the mean number of misspelled words in the population of student essays. We talking about mu or pi in this one? Mu or pi? How do you know mu or pi? Mu, Chris, why? Give me one word that's in there that tells me we're talking about mu. Standard deviation, that'll play. We talk about the mean and we talk about the standard deviation. We know we're dealing with mu. But in the case of this problem from Dr. Patton, she said that the standard deviation is 2.44. She said that her section had 40 students, and she said that the mean number of misspelled words is 6.05. And we want a 95% confidence level. My question, Z or T? Z or T, how do you know Z or T? Katie, I want to come back to you. Z or T, how do you know?
Z does it gives you population.
Z because it gives you population standard deviation. English teachers know that you are correct. I know that you are correct too. Very good, Katie. Because you have sigma, you need Z. Anybody out here? Anybody out here that knows 95% Z off the top of their not so bald head? Drew knows it. What is it, Drew? Yeah, something about 2. 1.96. Because it gives you population standard deviation, you can use Z. Column Z, 0.96. Do I get the values right on there? Sometimes around this time, I move decimal points or make 2s look like 4s. What's up, Perry?
Why did you use the Z-score again on that chart? Why did you not use it again?
See the problem? It says we have a population standard deviation. Population standard deviation, why that's sigma. When you have sigma, you use Z. Our 95% confidence interval for mu, x bar plus or minus Z times the standard error. I need to calculate the standard error here. 2.44 divided by the square root of 40. Never going to get there. Probably like 0.40. I don't know. Weird noises. 0.386? Wow. I should guess with weird voices more often. So you take standard deviation divided by the square root of the sample size. I like to write sigmas over n's or s's over n's so they're right where they need to be to calculate this stuff. 2 decimal places works for me. I think that's 0.39. So we're going to have a margin of error of something around 0.8, probably like 0.79, 0.78. What do we say? Which one do we want? 0.79 or 0.78? Chris, what do you say? Margin of error?
0.75.
0.75? Wow. That decimal dust is bigger than I think it is. 0.75. Confirmation? 0.756, maybe 0.76. But let's see what we have for options here. Yeah, we'll be all right with 0.75 for rounding. It'll make math a little bit easier. But let's call it 0.76 because I saw the right answer there. 6.05 is 0.76 means the upper bound, excuse me, 6.81. And I see one of those which has an upper bound 6.81. This one. 48 down, double deuce to go. But as it turns out, it's up to you to look up a bunch of t-values. I'm not looking up t-values. We got 22 minutes to go, 22 questions to go. You can look up t-values. Does anybody in here need help at me pointing to stuff on tables for t-values? I ask it in the affirmative because thumbs are tough to raise. What do we have down here? Oh, wow. We got some true-false questions. We got some questions on T. But more or less, we got 3 more questions where we got to come up with some stuff. Question 55. Recent study of the American Automobile Dealers Association revealed the mean amount of profit per car sold for a sample of 20 dealers was $290. The standard deviation of $125. What are the endpoints? 95% confidence interval for population mean. Is any information that we're provided up there population information? Is any information provided up there population? So the standard deviation population. Nope. None of the information provided up there is population information. An entire first sentence describes the sample of 20 dealers, their mean of 290, and their standard deviation of 125. Each piece of information there, X bar, S, N. Each piece of information in that question is sample level information. And we need to come up with a 95% confidence interval. So let me turn this one up to you, Curry. You ready? That standard deviation, is it population or sample? Good. Because there's that entire sentence is sample information, so that's sample standard deviation. If we have sample standard deviation, are we using T or Z? Good. Use T when you have S. If you have T, there's something else we need, Curry. What else do we need when we have T? We're working towards a confidence interval. I appreciate the dime, Jax, but it's not what we need right there. When we are looking for T, there's something else we need. What's the other thing we need? Yeah, we need the DF. Otherwise known as degrees of freedom. Christine, how many degrees of freedom in this problem? 19 n minus 1 or 19 degrees of freedom in this problem. It's a 95% confidence level. Is that what it says, 95% confidence level? Yeah. So we need to come up with a T value, 95% confidence level, 19 degrees of freedom, 2.093. X bar is 290. T is 2.093. Standard error, 28. $28 seems reasonable. Confirmation on 28. 120 over 125 over square root of 20. Good enough. $28 sounds good. 2 times 28 bucks should get me something around $56 and some odd cents. $56.27. How about $56.28? What's the value from a margin of error? Christine, you got that one too?
Yes, 58.5.
58.5. That is so hard. You should get better at it. That looks like 348.50 to me. And maybe the lower bound is Taco Bell. $348.50, 55. So we got about 16 minutes before the let's forget who is it? The fashion club, the fashion marketing club comes in and kicks us out. So I just want to be mindful that we still have about 12 like true or false questions to go over. And in case they spur discussion, I want to be able to have some time. Do we do 56 and 57, or do you think you got confidence intervals? Yeah. We've done about 15 of those. If you haven't done the practice quiz yet, do the practice quiz. People want the key. I took a picture of it. Maybe I'll upload it to Instagram and get some followers. Or maybe, do you guys still use Twitter? If I just upload it to Twitter and hashtag it finance217, I'll make you find, I don't know. Let's go to the next problem. But yeah, take a look at that, because I got to tell you, that practice quiz looks so much like the actual quiz. It's real. 58 of 70. A point estimate is a single value used to estimate a population parameter. I want to see some hands this time. Finish strong with me. You can tell I'm winded. Who says true? Who says false? That's not nearly enough hands. That's not nearly enough hands. Nobody in the top row raised their hand on this side, except maybe Jax, but I think he was just fixing his hat. Still, or hiding behind it. A point estimate is our best guess for a population parameter. Who says true? Who says false? Jane, come on. What are you doing? What are you doing?
Can you refresh us on the point estimate?
Are you killing me? No. The answer is true. You are killing me. A point estimate. Yes, in fact, a point estimate is our best guess for whatever we're trying to estimate. This whole day that we've been calculating confidence intervals, it's the suggestion that there's some value out there that we don't know. And I can give you a single point, and that single point is my best guess. But I'm going to add or subtract a margin of error around the point estimate to hopefully give you a better idea of what the population parameter might actually be. 58, true. 59.59, a point estimate is a range of values used to estimate a population parameter. Who says true? Who says false? Why is it false? Why is it false? Katie?
Well, it's only one number. The range would be like the intervals.
Exactly. A range would be an interval. A point estimate is one value, but a range of values would require an interval. 60, an interval estimate, is a range of values used to estimate a population parameter. Who says true? Who says false? Do you need a refresher on intervals as well?
No, it's so bad.
That's okay. I appreciate you letting me know that, though. So you got a confidence interval, and a confidence interval is effectively an estimate. So a confidence interval estimate starts with a point estimate. I can't see you, but a confidence interval starts with a point estimate, and you add or subtract the margin of error around that point estimate. And that's how you get to the full interval. So 21 is true. Or 60, 21. 60 is true, an interval estimate. But it doesn't say a confidence interval estimate, and that's fine because we add the confidence part depending on if we're talking about a 90% CI, 95, 99, or so on. But regardless, those are all interval estimates. 60 is true. 61, the 95% confidence interval states that 95% of the sample means of a specified sample size selected from a population will lie within plus or minus 1.6 standard deviations of the hypothesized population mean. Who says true? Who says false? Who thinks this is a tricky one? Why is it tricky, Drew?
Well,
Okay. So let's say we're talking about Z. Are you comfortable then? A little bit more? Brendan, you seemed a little uncomfortable. You better now? Chris, you better yet? Why not?
I don't know so much how.
True-false questions, when they're long, tend to send people thinking that something's wrong about it. Jackson, what are you thinking?
Is it false because you're using the samples to predict the population, not the samples to predict the rest of the samples? Makes sense.
Yeah, it does make sense. Yeah, you're getting there. You're getting there whether or not you know you're getting there. Katie, can you get us the rest of the way?
Well, I was going to say it's false because it doesn't take into account any standard error.
Yeah. So the challenge here, other than it being complexly worded and really a corollary of the central limit theorem, and this is what Jackson's actually getting at, because if you're using sample means to estimate things, it's not that you're estimating other samples. Within 1 or 9/6 standard deviations is wrong. Standard errors is more like, because we have a specified sample size. We use standard errors to come up with those things. But there's a lot that can throw you off here, including the fact that A is false and B is true. A is false and the correct answer. The big challenge being that it says standard deviations and not standard errors. That's all we're talking about now is anymore, standard errors. 62.6.2, one factor in determining the size of the sample is the degree of confidence selected. This is usually 0.95 and 0.99, but it may be any degree of confidence that you specify. What do you think? Katie, what do you think? You think true. Why do you think true? Because it sounds all right? Because it is true? I ask people to refute things when they're false. That's why it's true. Because I would ask you to refute it if it were false. What do you think? Do you think it's true?
I have no idea.
Who has no idea? Who's just straight up like, I got nothing? All right, so that means that most of you have something. What is the something you have? Lauren, what's the something you have?
I think that it's true.
Why do you think it's true?
Maybe because, like, when it's with one factor, I just feel like it's a factor.
Say again a little bit.
I feel like when we're getting at one factor, determining the size, I think it's one factor, but it's not like
Yeah, Katie?
I feel like it's false because it's a factor in determining the interval, not the sample size.
Oh, so the sample size is just a thing that happens. We just take a size.
Well, it's usually stated in the problem.
Yeah. So this is one of those tough discussion questions that we may not have spent a whole lot of time, because we don't have the time to discuss sampling procedure in here to get into the detail of statistics. So you can think about how big of a sample size you need based on how much confidence you require. On the other hand, if you look strictly speaking at the formula, the only thing in the formula which is affected by the confidence level is that Z or that T value. So in determining the size of the sample size is usually just determined for you and given to you. But you still, as a researcher, have some responsibility in determining how many observations you make. Because if you don't make a large number of observations, your standard error is large. If you don't make a large number of observations, that large standard error will pretty much get in the way of any level of confidence that you want to have. Because you can have a large level of confidence, which will give you a wide interval. You can have a small sample size, which will give you a wide interval. But you sort of need to be mindful of how confident you want to be in the results that you're providing when you determine your sample size. So strictly speaking, if you only look at the formula, we can think about this as false. But as budding researchers, you do have to be mindful of that confidence level when you choose your sample size. So we'll go with true on this one. '63, to determine the value of the standard to determine the value of the standard error of the mean, the standard deviation is divided by the sample size. Who says true? Standard error is standard deviation divided by sample size. Who says true? Who says false? Listen, how long have we been doing standard error? Why are you guys saying false? You guys, we've been doing it long enough. You recognize that one of the common errors here is to forget to take square root of the sample size. Good work. 63 is false because you got to take square root of the sample size. 64, a Z statistic is used for a problem involving any sample size and an unknown population standard deviation. Rudy, if I don't know the population standard deviation, do I use Z? I do not know population standard deviation.
That's population.
But I do not know population standard deviation. Do I use Z? Question 64 is asking that. Let's say I do not know sigma. Do I use Z? Nope. True or false in this question? Correct. Very good. Which statement is correct about the T distribution? The mean is 0, the shape is symmetric, all apply, or its dispersion is based on degrees of freedom. That's a strange order to put those response items in. What's the answer to this one? Lee, what do you think? You think it's D? Its dispersion is based on degrees of freedom? Yeah, its dispersion is based on degrees of freedom. Do you suppose its shape is symmetric too? The T distribution is very much like the Z distribution. It's just a little flatter. Its mean is 0, but its standard deviation and shape is based on the degrees of freedom. D is truly, but it's a little bit more than that. Do you know how much more than that it is? All will apply. All will apply. All will apply. 66. The sample mean is the best point estimate of what value? Sample mean is best guess for? Who's got this one? Yeah, Reynolds. Population mean, very good. 67. Distribution of students T. That's the T distribution we're talking about. Students is capital. If you want to know more about the students T distribution, you should read about Guinness beer, because that's where the students T distribution actually came from. I know, silly, right? But a guy actually was working for Guinness at the time and was working on making sure Guinness was good and for strength and whatnot. So in order to do that, he conducted a bunch of tests and found these things that were happening under the normal distribution, and he wanted to share his results with the scientific community, but because he was working for a company and proprietary laws and such prevented him from sharing it under his own name, he submitted his research to the academic community under the pseudonym Student. So it's now referred to as the students T distribution. Anyway, the T distribution is characterized by one of those. It does not have a mean of 1 because the Z distribution does not have a mean of 1. It does not have a mean that depends on the sample size because it's just like the Z distribution. And what is the mean of the Z distribution? 0. The mean of the Z distribution is 0. So one of those two things applies to the T distribution. But a normal distribution with a mean of 0 and a standard deviation of 1 is also known as what? Normal distribution with a mean of 0 and a standard deviation of what? Also starts with letter S. What you say? It's an S word that we use a lot. What's a Z-score? Z-score has a synonym. Standard score. A normal distribution with a normal distribution with a mean of 0 and a standard deviation of 1 is the standard normal distribution. B is not the answer. D. These are questions that we didn't discuss in class, but if you've had a chance to watch the lecture videos, or if you stopped watching them, bad idea, because that's how you miss these questions. The lecture videos covers this conceptual stuff, because we spend most of our time in class working on math problems. 68, when we use a confidence interval to reach a conclusion about the population mean, we're applying a type of reasoning called what? What's the type of reasoning that we're using here? There's a number of those which you can eliminate, which are definitely wrong. What's one of those up there which is definitely wrong? Drew? Graphics is definitely wrong. So we've already increased the probability we get this right from 1 out of 5 to 1 out of 4. Who can definitely get rid of another one that's totally wrong? Curry.
E.
Which one's that? Is that the right answer or the wrong answer?
Wrong answer.
Sorry.
Right answer?
It's the right answer.
Yeah.
We're making a statistical inference. That's what we're doing. Descriptive statistics is what we spend the first half of the semester doing when we're talking about describing observations that we actually see. We say, I take a sample and I describe those samples. That's descriptive statistics. The normal distribution is the thing which exists in the world, but it's not a type of reasoning. Making a statistical inference, trying to infer about what we cannot see and do not know, that's what is happening here. 69 out of 70, 1, 2 to go. University officials say that at least 70% of the voting student population supports a fee increase. If the 95% confidence interval estimating the proportion of students supporting the fee increase is 75 to 85%, What conclusion can we draw here? Well, 70% is not in the interval. So maybe one of those is right. The interval estimate is above 70%, so maybe we can make a statistical inference. Who's got some part of this that's correct? Katie, what do you think?
I think it's
70% is not in the interval, so assume it will not be supportive. Well, 70% is not in the interval. That's true. But they say 70% is what's needed. That's what we say is needed. What was the interval that we observed?
95.
It was a 95% confidence interval, but what were the boundaries of the interval that we observed? Right. This is what we observed, and that's what we need. Based on what we observed, does it look like we have what we need?
So
It's not B either. We don't need another sample. Stephen, why are you going with D?
Because it is true that the interval estimate is above 70%, and you can infer that at least 70% or more is in that conclusion.
And that's good. D. So our entire interval estimate is above 70. Basically, we're saying there's a 95% chance that when the students actually vote, they will end up somewhere between 75 and 85%. And all of that is above 70%, which is what's needed. Question 70 out of 70, and then everybody can follow Abby out the door.
Sorry, I had a meeting.
I know, me too. I'll see you later.
Bye.
Bye. If 95 and 98% confidence intervals were developed to estimate the true cost of this thing called an MP3 player with a known population standard deviation, what differences would you say they have? Would their Z's be different? Would their point estimates be different? Would their standard errors be different? Or would their sample sizes be different? The only thing that's different between the two things is the confidence level. What does that change about their confidence intervals? We change the confidence level, Chris? Just the Z statistic, and that's it. Hey, 70 questions. Good work, y'all. So now I got to go back through those 40s and make sure that those questions in the 40s correspond to the correct 90 and 99% stuff. Also go through the front half of those true-false questions to make sure that stuff is read up in that. You're also going to see, probably because I made a change in there, that some part of the homework assignment currently says it's not released, scores are not released or something to you, maybe or maybe not. That happens anytime we make a change. There's 6 check boxes that I forget to check. 1 out of 6, at least one. But hey, thanks for sticking around. Well done. Hopefully you can do some confidence intervals. See a bunch of you tomorrow.